Salut tout le monde, je m'appelle Sam DUTTON, je suis developer advocate chez Google. J'ai une photo. C'est ma maison pour ce soir. J'aime bien, il pleut, mais j'aime bien Nantes et Airbnb. Malheureusement, je ne parle pas bien français. Maintenant, je parle en anglais. Excusez-moi. So, yeah. This is our new brand. Joking. If you want to follow along with these slides, by the way, they're online. I realized looking at these slides, there's a lot of links. But if you want to follow along, it's easier if you look at the actual slides. Yeah, my name is Sam DUTTON. I tweet quite a lot about WebRTC at SW12. I'm going to talk about, what's been happening with WebRTC, some stuff that's kind of in the near future, and just a few kind of, warnings, public service stuff. And I hope I can show that Chrome is not always a scumbag. God, I love their talk. Anyway, the first thing I was thinking about is, who is using WebRTC now? And I looked at, I don't know if anyone's seen it, there's a blog Geek, a guy called Levi that tracks this, and there's like more than 800 companies now using WebRTC in some form, which is amazing. I think it's up like, it was 550 back at the beginning of the year, so that's a lot. And there's been a bunch of acquisitions, there's like 29 that we know about now of companies that are building with WebRTC. This is actually in like internal figures. Sorry, no numbers, but you get the general picture. This is people using RTC peer connection in Chrome, which is obviously looking pretty healthy. It's a good time to be a WebRTC engineer. Some big apps, of course, using WebRTC. If you also check out the stuff that's on WebRTCHacks.com, you'll see that WhatsApp also is apparently using components of WebRTC. There's great stuff done by Philip Hankey, by the way. He does Wireshark analysis of WebRTC, of apps, and looks for see what kind of WebRTC usage they're making. So this is pretty good. Kind of less obvious stuff is, it was pointed out to me that in MailChimp, it's kind of, progressive web app design. If you go in a browser that supports get user media, it asks to take your photo. Otherwise, it falls back to, you just got to select one. So this is kind of sort of slightly unexpected uses of WebRTC. This one I really like. It's kind of old-fashioned idea. It's audio conferencing, like what used to be called phone conferencing. And the point is that it's done in binaural stereo, and the sound quality is fantastic. The company's called Voxy. They're French too, which is good. Yeah, and something kind of unexpected. So there's over 3 billion apps have been downloaded that have WebRTC components, and 1.5 billion or more now of the browsers out there supporting WebRTC. Just a couple of things I wanted to talk about. I don't know if people have heard of the Alliance for Open Media. I think a lot of companies are getting to the point, and developers getting to the point with codecs and video technology, just thinking enough is enough. And the Alliance for Open Media is kind of designed to address that. A bunch of people involved, also on the list, Amazon, Mozilla as well, and other companies working on this, trying to combine forces to come up with open codecs that work really, really well. The reason it's important for WebRTC is that there's a particular focus on mobile performance, on no matter what the device, but also on real-time video delivery. So this is a big deal for WebRTC, I think. And yeah, there's a lot of codecs out there and a lot of people working on this. So we really hope that people can combine forces. According to 9 to 5 Mac, there is no mention of H.265 in the Apple, the iPhone 6S announcements. Anyway, it's intriguing. We'll see where they go. Edge, of course, Microsoft has been doing great things developing Edge over the last couple of years, and yeah, VP9 support showing up there, and obviously support for WebRTC in the form of ORTC, get user media already working. And yeah, I'll show you later, our samples are already working on Microsoft Edge. Another thing you might have heard about was this concern about IP address leakage with WebRTC. So the story goes like this: that you know, WebRTC is essentially it's a P2P stack. It looks for the best routes, the most efficient routes between two browsers, two endpoints, and that may mean that it chooses something different from the default HTTP interface. So in other words, it might not go through a VPN. This is a problem for people who want to maintain an anonymous public IP if WebRTC is using a different route and thereby exposing something else. The flip side is that it can be a problem for companies that are running a VPN that, like, say, want people to do that for like email or whatever, but they don't want people pushing HD video calls through that. So it's slightly complex, and I mean, how to handle this is tricky, in terms of UX, UI, like how to pop something up that makes any sense to a normal user about what's happening. So what a couple of my colleagues have done is built this extension, Network Limiter, and what this does is it forces WebRTC to use the default HTTP route, which means if you're on a VPN, it will always go through the VPN. Obviously, that may not be the optimal route, but it means that people get that behavior if they want it. I hope your phone is okay. The plan is in Chrome 47 to introduce this by default if your app doesn't ask for microphone and camera permissions. So in other words, if your app asks for microphone and camera permissions, your app will then work just as it will now and take the most efficient route. But it will be clear then to people that if they've done that, then that may not be going via their VPN, and they could still use, obviously, the extension to force that not to happen. Really like it if you're working on apps, if you could try out the extension, if you could try this out, take a look at Chrome 47 and report any kind of crazy behavior you're seeing, anything that doesn't seem to work as expected. Another thing with Chrome 47, please remember that get user media will no longer work except on secure domains, so only on secure origins. So HTTPS or localhost. Just bear that in mind. That's coming up, and you'll see a warning in the console if you try and get user media in that way. Some new stuff that's been, sorry, this is shamelessly from the Chrome team, but I think there's a bunch of really good things going into WebRTC. So this is kind of techie, but this is a huge deal on WebRTC, which is to reduce problems with echo. In the past, the way echo cancellation worked was that it was reliant on essentially using the operating system to try and guess echo and then deal with it. There's been a shift to a much more dynamic method of echo cancellation, which is actually comparing the output with the input and then adjusting accordingly. There was, I believe, a complete failure for some people, like back in June or something, of echo cancellation, which was because of some audio, like kind of complex audio stack problem. But anyway, that is fixed. It's something we'll keep working on because this changes all the time. It's, of course, a really crucial part of WebRTC calls to stop echo. We're also going to be seeing, from Chrome 45, but still working on this, better screen sharing. This is really important for companies like Citrix or anyone that's doing screen sharing, of course, at the moment via an extension. I think I've got a demo of this actually. Let's see if I can play this video. It's probably a bit hard to see, but essentially you've got the old on the left, the new on the right, and you'll see as scenes change, So visible here, but in the next one, you'll see that you're getting a much more responsive result with the new version of screen sharing. So that's great. Again, it's kind of crucial for a bunch of different applications. Apparently, it's particularly bad in the existing version with like spreadsheets that have lots of lines and so on. If you're interested in this stuff, check out the screen capture proposals. This is a really interesting API proposal that has the kind of concept of the physical surface of a display and the logical surfaces of windows and tabs and so on to give more more fine-grained control over screen sharing, tab sharing, and so on. Kind of interesting stuff. Also thinking about that. This ability to work with DOM elements like Canvas, to use those for streaming. This is kind of, to me, this is a really interesting concept. It's this idea that any DOM element could become something that you stream. And yeah, the API for that is media stream processing. I don't know if anyone's seen this. Again, I think could be a big deal for working with mobile devices, especially. It's an API that essentially gives you access to the features that you expect on a camera. So stuff like autofocus and red eye and all the rest of it. Yeah, that's under development, and check out the proposals for that. Someone told me actually that now it's I think more than 50% of people developing for WebRTC are now developing on native. It's kind of a shame about the name, but anyway, there's nothing we can do about that. But there's lots of good performance improvements, both on the render side and the capture side, on native implementations of WebRTC, and big improvements in battery performance. A stack of this stuff, I think, is going to become more and more important as we're designing for, contexts in emerging markets, coping with any context anywhere where there's spotty connectivity, high data charges, low spec devices. There's a lot of effort going into this. I don't know if anyone's traveled in India or elsewhere, but it's it can be really, really hard to make anything like a decent video call at the moment. This would be huge if we can get this to a point where we have WebRTC working on devices with like very little battery life and very poor connectivity. These are just to back that up, just some graphs really showing improvements in battery power. I think this might be between Chrome 45 and 46. Great improvements. A lot of this is moving stuff to hardware, and also I believe reducing the number of repeated frames. So, like something like a 75% reduction in GPU usage there, which is great. Just think about mobile audio too. A couple of big improvements there, just happening with native. Really about latency, which is great. But please, obviously, tell us if you're experiencing any strangeness there. A couple of other things with mobile video. We've got hardware support for H.264 and VP8 on Android, and H.264 on iOS. More stuff coming, and there's a bug there if you want to track their stuff and see where we're going with that. And again, this is doing great things for improving performance in those situations, reducing CPU drag and increasing battery life. This little graph, this is a huge deal. This is some fantastic work by the WebRTC team at Chrome. What this represents are these like red dots are the actual time that frames were rendered for. The scale on the left is microseconds. So did some testing on this and basically discovered, the blue dots are what the app essentially thinks, what the app actually thinks is the length of the frame. So what this represents is this problem that frame length was all over the place. This is in Chrome 45, and what that meant is that that video playback is much more inclined to be janky, and got all kinds of problems there with smoothness. What you're aiming for optimally is around the 33 millihertz level. So that would be 30. You can't really see these at all, but that's 30. That's 60,000 microseconds. So some work done in 46, and now we've got this fantastic result, which is very, very even frame length there. A few outliers, but really impressive there, making much smoother experience with WebRTC. I want to talk about some stuff on desktop still, although these will make their way to mobile. Set Sync ID is a fantastic thing for it. Enables you to choose the output of your stream. So in other words, at the moment, to choose audio devices. This is great if you want to, have audio output to, say, a Bluetooth speaker or whatever, something other than the default. And the kind of flip side of that is media devices, enumerate devices method, which I don't know if people had seen get sources, which was a way of getting the source devices, microphones and cameras and so on. Enumerate devices does that in a kind of slightly simpler way, but also allows you to get output devices. The last one there is a nice feature added to data channels, which is an event that allows you to check if the data channel buffer is getting low. So essentially it's like, is there any data left? Is there more? Do I need to go and get more data? And essentially you can now do that with a handler for the buffered amount low event, which is really useful. And yeah, we'll be talking about support for IPv6. Let's just have a look actually at an example of that. This is our, I don't know if people have seen this, but this is the home of our web samples for WebRTC. Let's see if I can open this. So this is showing, it's not really much, a little bit hard to see here, but essentially, I'll tell you what, it's opened in HTTP, which shows you the problem here. This is the message you'll now be getting. This is running in Canary, so that's what you'll be seeing when it goes wrong and you need to use HTTPS. So let's change that. Wait for that to ask permission. So yeah, essentially I've only got one built-in microphone and one output destination and one video source, but essentially this is allowing you to choose different sources, a demo of that. There's one more here actually if we look down these demos. Sorry, I'll get the other one. This is kind of doing the same thing, but it's showing you that you can essentially choose different local file sources as well as the remote stream there, essentially. So if I play this one, it's not even going to play on this, I think. But I could be choosing, my Bluetooth speakers or whatever, and the same for audio. And this is to represent the fact that you can make a WebRTC call which is audio only. You don't need a video element there. Just go back to this. So some other stuff that's kind of on the way, not quite here. So yeah, VP9 in WebRTC is going to be coming in, well, it's in Chrome 47. Chrome 47 is in stable by kind of the end of the year. Yeah, working on SVC support for that. So again, better quality, less bits. That's the general principle. Looking forward to seeing that when that comes into stable. And again, working on H.264 in Chrome. That's probably going to be kind of coming into beta at the end of the year for Chrome. And you can check the bug there. Media recorder. This is the ability to record audio and video in your apps. This, I believe, is the single most requested feature request on chromium.org. And it's been implemented. It is behind a flag, but it's in Chrome 47, which is fantastic. It's video only. And what would be really useful to us, will help with the development, is if you can kind of tell us what your usage scenarios are for this. If we just have a look at it, it's a pretty rough demo here, except I haven't got it. Hold on. Let's see if I can show the speaker notes. Hang on. I'd really like to show you this. Open up the demo for this. This is very hard to see on this screen. Let me see if I can. There we go. So, okay, let's see if I can. Chug. Okay, no, I don't think this is going to work here. So, okay, okay, there we go. So, sorry, this is rough, but it works. So you can see that it's, we've got a get user media call there. I'm here. Now I can do one of two things. I can either stop that stream and start playing it back in a video element, or I can download the data. Of course, this is really powerful. So if I do some stuff, you can see that, it's now playing back the recorded version of what I was looking at there. I just wanted to quickly show you the code for that, because it's pretty straightforward. So I'm just going to the GitHub repo for this. If people can see that code okay. Let's try and increase the size a bit. Okay, so what we've got here is a response to a get user media call. And when that's successful, we're creating a media recorder object with the stream and telling it the codec to use. And then we're adding handlers here for the events that come through from the media recorder. So if we look at the first one of those, recorder on data available, if you've got some data there in the event, there's just some checking there, it just adds that data to an array we've got, which is called recorded chunks. It's just an array. We're just adding an array, adding chunks to the array there. If alternatively you want to stop the streams and play back data, then it stops the recorder, and then we get a buffer from creating a blob from the array of chunks that we recorded, and then we're simply setting it's gone off the screen, but you get the picture. We're setting the source of a video based on that blob. If we want to download the data, we save the byte array, which is, there's a kind of helper function up here, creating a blob and so on. And then essentially that's creating a download URL which corresponds to the file. So it's actually pretty straightforward, which is nice. And we look forward to more work on that and hearing what people are actually using that stuff for. I can see some really amazing usages with this, doing stuff like, you could record a ski run on your phone, getting location data, other sensor data plus video, put the two together. You've got kind of synchronized timed media, which is a really nice idea, I think. Anyway, some other stuff, faster ice and turn and better radio handling and so on. Yeah, some more good stuff going on there, kind of behind the scenes. On the way, one of the ones here that particularly appeals to me is web audio being hooked up to WebRTC on the output side. So in other words, that you could feed a stream from a WebRTC call into web audio and do some processing or handling for that. So, you know, visualizing or whatever you want to do with web audio on that side. I won't talk much about the unified plan. You can follow the bug there. It's a project initiated by Mozilla, and yeah, so also WebRTC for iOS on Chrome. Google and Microsoft and other companies are working on ORTC. This is a new approach, a new API for WebRTC, which is hopefully going to make it, in some components at least, by the end of the year in what will be called WebRTC, still like WebRTC 1.0. The kind of core of ORTC is to cope with the problems. I don't know if people have built WebRTC apps, but WebRTC apps are reliant on something called SDP, which is a kind of sort of a legacy format. And to do stuff like change bit rates and so on, you've got to munge this rather arcane format, and it's just not very webby. And ORTC is designed to address that. But it also gives us the ability, and this one is huge if you've ever tried to build a WebRTC video chat app, do things like change the camera on the fly. At the moment, that's like ridiculously complex. You know, you have to essentially stop the call, change the camera, restart, reinitiate, and, you know, set up again. Whereas the point of the ORTC interface for this is that you'll be able to do that on the fly, and that will be easy. And you'll be able to do stuff like change bitrate and so on with object methods, not through some insane regexing of weird data formats. So yeah, this is great. It feels like there's been a lot of progress with this with Microsoft and Google and others. So hopefully we'll be seeing that partly by the end of the year, but also next year as well. And then, yeah, there's plans to move on there to give us access to things like SVC and so on, and more of the same, really. The ability to control stuff in I don't know, to give you more fine-grained control without having to do strange stuff with SDP. And the ability to not use SDP at all, if you want. I don't know if anyone knows what this is. Any Australians in the room? Anyway, this is a bug. That's what Australians call a bug. It's a edible crustacean. Anyway, because I want to talk about bugs, just wanted to point to this tool. If you haven't seen it, it's really useful. Test.webrtc.org essentially has a bunch of tests. Hang on, I'll show you. If I actually open it. Yeah, so it has a bunch of tests. I might have to reduce the size here a bit so you can see what's going on. A bunch of tests that check microphone, camera, and so on. You know, this is useful not just for WebRTC, but for anyone who wants to check the network conditions and microphone and camera and so on. So you can see it's running through a bunch of stuff for the local setup there. You can tweak some settings there, so change the source that you're getting this from, microphone and camera, and add stuff to select a different turn server and so on. Okay, yeah, all right, that's pretty much expected. Still going there. And then anyway, the point of this is that you can then either download a report or actually there and then file a bug report. So in other words, if you're experiencing a bug with WebRTC, this is a really good context for reporting the bug, because you can report the bug and give like the full detail about your context at the same time. So we really recommend that, and it, as you can see, it doesn't take all that long to get through, and a stack of information about what kind of bandwidth we're getting. I was hoping I'd get to that. It's still thinking about it. Okay, yeah, we got through there. Okay, anyway, right, I'll let that finish. So please, we really like your bugs. We really appreciate them. Thank you. And that has all the information about how to report bugs. Feel free to use the test tools there. Okay, so I wanted to just show you where our kind of sample code lives now, because there's a stack of stuff there. If you haven't seen this, github.com/WebRTC has lots and lots of useful things. I just showed you test RTC. If you want to make contributions, that's the place to add to that. We will actually be moving WebRTC.org there as well, so people can contribute as if it, like any other open source project. The other tool that's there is a library called Adapter.js. You can use this, recommend this via NPM, but also via Bower for your web apps. Essentially, this is a shim that insulates you from changes to APIs, and the most important thing, which has now expanded it by a few thousand lines, is that it now works with Microsoft Edge. So a really useful tool for anyone working on WebRTC apps. And again, please tell us if you need us to add anything if it doesn't work as advertised. The Canonical WebRTC video chat app, if you haven't seen it, is called AppRTC, and the code is there. I'd recommend looking at that if you're thinking about building WebRTC video chat of any kind and you haven't looked at that before. That's the best place to start. And lastly, the samples. I showed a few there. This is our repo of web samples. We have all kinds of stuff. We welcome contributions. We've got the GitHub Pages site I showed you before that essentially has all those samples online. If you would like to have a look at other stuff, technical questions, the best place is Discuss WebRTC, webrtc.org. If you go to g.co WebRTC, that's a very long list I maintain of WebRTC resources. Two things there I'd recommend if you've started working on Android or iOS, or you're thinking of these two guides, just both really good places to start with iOS and Android development for WebRTC. So a stack of stuff there. Please suggest to me if I'm missing anything. And of course, chromestatus.com is a great place to check about implementation of the APIs I talked about. One thing about chromestatus.com, it's maintained by the engineers that build the stuff, so it is generally very, very up to date. So it's a really accurate source of information. Yeah, that's it from me. The slides are at that URL. There's more links in the speaker notes. Please, talk to me if you've got any questions about WebRTC. I'm happy to take questions now. Or if anyone needs to email me, my address is Dutton, D-U-T-T-O-N, @google.com. Really happy to take questions about WebRTC. Yeah, thanks.